In part 1, we had one sensor and one row of numbers. Real engineering data almost never stays that simple. 3 sensors, 7 days. That's a grid, and MATLAB calls it a matrix. And a matrix has a trap a plain vector doesn't. Ask for the wrong element, and you usually get no error at all. You get a perfectly reasonable-looking number that happens to be the wrong one. Same square brackets as before, with one new piece of punctuation. A semicolon starts a new row. M equals sensor 1's week, semicolon, sensor 2's week, semicolon, sensor 3's week, all inside one pair of brackets. Spaces separate the columns. Semicolons separate the rows. 3 rows, 7 columns, 21 readings. Rows are not allowed to be different lengths. Leave one reading out of row 2 and MATLAB refuses. Dimensions of arrays being concatenated are not consistent. A matrix is a rectangle, so every row has to be exactly the same width. If a sensor missed a day, you still fill that slot in, usually with the special value non, which is short for not a number. What you can't do is just leave a hole. When you know the shape but not the contents yet, build the empty rectangle first. Zeros of 3, 7 gives you a 3 by 7 grid of zeros to fill in. Ones does the same with ones. And zeros of size of m gives you a blank grid exactly the same shape as one you already have, which is what you want when you're storing one result per reading. To ask MATLAB for the shape, call size. Size of m returns 2 numbers, rows first, then columns. 3 and 7. You can catch them separately with open bracket r, c close bracket equals size of m, and now r is 3 and c is 7. Numel of m gives the total count, 21. Rows, then columns. Remember that order. It never changes. Indexing takes 2 numbers now, and the order is that same one. Row first, column second. M of 2, 3 means sensor 2, day 3, 77 degrees. The 2 picks the row, the 3 counts across it. 2 coordinates, 1 value. Now watch what happens when you flip them. M of 3, 2 is sensor 3, day 2, 69 degrees. It didn't crash. It didn't warn you. It just answered a different question from the one you meant to ask. That's why row, column has to become muscle memory. The wrong order gives wrong numbers, silently, all the way to your final answer. The colon from part 1 now means everything in this dimension. M of 2, colon is row 2, every column. One sensor's entire week. M of colon, 1 is every row. Column 1. All 3 sensors on Monday. In part 1, you read the colon as through. Here, on its own, read it as all, and works in both dimensions, independently. M of end, end is the bottom right value, last sensor, last day. M of 2, end minus 1 is sensor 2 on Saturday. And you can mix end with a colon. M of end, colon is the entire last row, however many sensors you end up adding. Put a range in both slots, and you carve out a rectangle. M of 2, 3, 4, 6 means rows 2 through 3, columns 4 through 6, sensors 2 and 3, Thursday through Saturday. 6 readings, handed back as a new 2 by 3 matrix. Rows first, columns second, every single time. Everything you just saw works on the left of an equal sign, too. M of 1, 1 equals 71, fixes one bad reading. M of 3, colon equals a fresh row of 7 numbers, replaces sensor 3's entire week. And M of colon, 7 equals 0 sets. Sunday to 0 for every sensor at once. One value spreads across the whole column. Growing works, like it did for vectors, one dimension at a time. M of 4, colon equals 7 new numbers, adds a 4th sensor. Or stack the pieces yourself. Open bracket M semicolon. New row glues a row underneath. And open bracket M, new column glues a column onto the side. The piece you add has to be exactly the right width, or the right height. To delete, you assign empty brackets, same as before. But in 2 dimensions, it has to be a whole row or a whole column. M of 2, colon equals empty brackets, removes sensor 2, and leaves a 2 by 7 matrix. Try to delete a single cell. M of 2, 3 equals empty brackets, and MATLAB refuses. A null assignment can only delete an entire row or column. Punch one hole in a rectangle, and it isn't a rectangle anymore. Arithmetic with a single number is easy. M times 2 doubles every reading. But put a plain star between 2 matrices and MATLAB does real matrix multiplication, the linear algebra kind, rows against columns. With 2 3 by 7 grids that isn't even defined, so you get incorrect dimensions for matrix multiplication. If what you meant was multiply each cell by the matching cell, you need dot star. Same for dot slash and dot caret. Plus and minus never need a dot, by the way. There's no such thing as dot plus, and apostrophe transposes. Rows become columns, and columns become rows. M prime turns our 3 by 7 grid into a 7 by 3 one. Days down the side, sensors across the top. Same 21 numbers, flipped about the diagonal. It's also the quickest way to turn a row vector into a column vector. Here's the one that quietly ruins homework. Sum of M does not give you one total. On a matrix, sum works down each column, so you get 7 numbers, 1 per day across the 3 sensors. Add a second argument to change direction. Sum of M, 2 works across each row instead and gives 3 numbers, 1 total per sensor. And sum of M colon in brackets adds up all 21. Mean, max, and min all behave the same way, column by column, unless you say otherwise. 2 more things about M colon in brackets. It stretches the whole matrix into one long column, and it does that down the columns, not across the rows. 68, 70, 65, then Tuesday's 3, and so on. That's the order MATLAB actually stores a matrix in, which is why a single index still works on a 2D array. M of 4 is the 4th value in that column order, 72. And ask a question instead. M of M greater than 73, and you get every reading above 73, again as one column. The copy myth from part 1 holds in 2 dimensions too. M2 equals M, then M2 of 1, 1 equals 999. M2 changed, sure enough. M did not. Assigning a matrix copies all 21 values into a brand new variable. It does not make 2 names point at the same grid. Same for a block. New M equals M of 2 through end, 4 through end copies. Sensors 2 and 3, Thursday to Sunday, into a brand new matrix. Change new M and M is untouched. If you actually want the original updated, you have to write the block back in. M of 2 through end, 4 through end equals new M. 4 things to take with you. Row first, column second, and the wrong order doesn't error, it just lies to you. A colon on its own means the whole dimension, and end works per dimension. Delete with empty brackets, but only whole rows or whole columns. And sum, mean, and max work down columns by default. Your challenge. For our 3 by 7 M, what does size of sum of M, 2 return? Comment your answer. I'll pin the first correct one. Everything from this video is on GitHub. Link in the description. Clone the Learn MATLAB repo and open the Arrays 2D folder. If you skipped part 1, it covers vectors, indexing, and the copy rule that everything here is built on. Run the files, break them on purpose, and tell me which error message you hit first.